All right, welcome everybody to Cityworks Innovate Conference 2021. My name is JD Cornelius, and I'm going to be the moderator for this session today. Today's session is going to be about creating actionable insights for water with Cityworks IoT and Trimble Unity Mobile, presented by Rami Naber and Umar Usman. Before we get started, I've got a couple little housekeeping items here I'd like to review with everybody. If you have a comment or a question, please go to the red Live Now button, click on that, and then you'll be able to scroll to the bottom, click on questions, and there you'll be able to ask any questions or comments for the presenters, and we'll be trying to monitor that through this presentation. We'll have some time at the very end to try and answer some of these questions. If you're having any technical difficulties, you can also click on the question mark at the bottom right-hand side or bottom right-hand corner of your screen, and this will give you some troubleshooting ideas. You may leave the session at any time by clicking the 3-stack button menu in the top right upper corner. Once you click that, you'll see a prompt to say to leave the meeting. This will take you back into the conference lobby. And we're asking them, please don't close your browser, as this could cause problems getting back into the session, into the lobby later on. Also, there is a ratings and review module on the navigation bar on the left-hand side. So you can write a review and rate the session. We encourage your feedback so we can make any adjustments along the way. And just lastly, a quick plug for all of our sponsors and exhibitors. So please visit our partners in the virtual expo hall that we have, and feel free to start a live chat with any of our sponsors or exhibitors that you see. Thanks very much. So at this time, I'll hand it over to Rami Naber and Umar Usman.
Thank you, JD, and thanks everybody for joining us today. I'd like to start by talking about some of the industry challenges and the solution that we took to market to solve these challenges. So the aging infrastructure is a global challenge. And as per the 2021 American Society of Civil Engineers report, America's drinking water infrastructure earned a score of C-, which means it's in mediocre condition, requiring attention. And the wastewater had a score of D+, indicating that it's in poor condition, mostly below standard, approaching the end of their life, service life. The report also identified that funding, maintenance backlogs, and lack of reliable data were 3 overreaching trends affecting infrastructure. Now, working with utilities and talking to utilities, we've seen challenges around the lack of visibility into asset performance on the distribution and collection systems. Also, lack of reliable asset condition and performance data, and the tools that are required to help our customers identify the cause of problems that are causing chronic repairs, and also to assist them in making informed decisions when prioritizing asset repair activities and support their capital planning efforts. Also, we've seen that many utilities still follow reactive asset management practices, fixing assets as they fail, which leads to higher operations cost and disruption of service and poor customer service. Also, some utilities have asset performance monitoring tools, but they're siloed and not integrated with their GIS and asset management platforms. So what we've done is we've integrated various technologies in our portfolio to create what we call the system of action, which was referenced during the general session today, providing a solution that collects reliable asset information, asset condition, and performance data to support your action plans while managing your assets. And if we start with the foundation, every aspect of utility operations and asset management depend on accurate data on the utility network asset. And Esri lays that foundation as the system of record for asset information. You can't manage your assets if you don't know what you have or where they're installed or where they're located. And then from that foundation, you could use Cityworks in the office to plan, dispatch, and manage work activities, and use field apps, including Cityworks and Trimble Unity mobile apps, to conduct asset inspection, maintenance operations, and cost tracking, and empowering your field technicians with the data and specialized tools to streamline field data collection process and workforce productivity. And then from there, use the Trimble Telog family of IoT recorders and sensors, which we'll cover in more details later today, with Trimble Unity remote monitoring and Cityworks software to support a multitude of water and wastewater asset performance monitoring applications. And then bringing in GIS asset details combined with this IoT KPIs and operational data all feed into Esri ArcGIS and Cityworks operational insights to create and share dashboards and insights within your organization, providing real-time situational awareness of water network operations performance and asset performance, and identifying and assessing high-risk areas or assets, and informing your action plans to prioritize maintenance strategies and supporting your capital improvement projects. So if we look at Cityworks in terms of there are 4 key activities in managing events and assets in Cityworks, starting with creating the work activities based on whether it's an IoT event or request from the public, then going out and performing inspections, dispatching those inspections and performing them using either Cityworks Respond or mobile apps where observations are captured. And based on these observations, Cityworks will create follow-up work orders to perform any necessary repairs and track more details on work performed, getting into project management, contract management, and the use of resources to track cost of equipment, labor, and material. And then all of this data that's being generated and recorded in Cityworks, we're able to perform reporting and analytics to bring this data into a spatial context within ArcGIS, providing an in-depth view to help organizations make informed operational decisions. And in regards to mobility, I wanted to highlight our recent release of the Trimble Unity Mobile for Cityworks product, offering a commercial off-the-shelf solution that integrates Cityworks version 15.7 with Trimble Unity Mobile. So Trimble Unity Mobile offers specialized workflows and tools, and as part of this release, we've included the integration with the EHWOX valve exercising machines to streamline the valve exercising workflow and data collection process. And with that, improve the quality of the data that's brought into Cityworks for analysis and insights. Also eliminate the need to manually import and export data between siloed systems. It's all integrated GIS-centric workflow. We also added, as part of the inspections, the ability to capture equipment and labor cost without having to create related work orders for cost tracking. And that was introduced in version 15.7. Trimble Unity already had support for high accuracy GPS mapping via seamless integration with the Trimble high accuracy GNSS receivers. This can be used to accurately capture the location of the asset that's being inspected, and then update the GIS data, ensuring that the GIS data is up to date and accurate, so that when crews go out in the future to locate that valve, they have an accurate location of that valve and information as well. And finally, we've added support for conditional questions while capturing observations, inspection observations. This is used to streamline the data collection process, eliminating the need to view and collect unnecessary questions. So that was all introduced in 15.7 and as part of the Trimble Unity Mobile for Cityworks product. And as for the IoT, I'd like Umar to cover the IoT portfolio.
Sure. Thanks, Rami. So I think one thing I really liked on the previous slide that you talked about is where the data is coming from to trigger this entire process around asset streamlining or actionable insights. And your data, your trigger for all of those set of activities is either coming from a customer complaint or an IoT device. So what we will be talking about in the coming slides is specifically what that IoT section of the data input, that gateway point, looks like over there as well. And what we call that IoT platform within Trimble is the Telog portfolio, which is a proven portfolio for IoT monitoring, specifically for the water and the wastewater industry. These are the RTUs or data loggers, which I'll explain in the coming slide, which have been there in the field for more than 25 years at this point. And they support a multitude of different applications, both on the water side and wastewater side, assisting with asset performance monitoring, leakage applications, non-revenue applications, and other applications over there as well. So they do cover a wide range of monitoring applications, really focusing on trying to move customers away from customer complaints that they're reacting to providing insights on your water network, both the distribution network as well as the wastewater network, collect the data for those applications and provide insights specifically associated with those applications. On the water side, there may be non-revenue water related applications. So if you're losing revenue on your data through leakage or unauthorized use or whatever the case is, all the way to pressure management, water quality issues. So you're proactively trying to manage your system in a manner where you're responding to what the field is telling you, as opposed to responding to what the customers are telling you. Now, on the wastewater side, Rami showed the grading for the US wastewater network was all the way down to D+, which I'm sure most people who turn on the news at night and sometimes see sewer overflows after rain has flooded the network, as an example, would not be too surprised about. Though we have data or equipment in the field over there, which provides us data on the sewer overflow conditions, level monitoring conditions, lift stations over there as well, to create the data from those type of fields over there. Now, all of this data is supposed to be giving you proper situation awareness on what your system is supposed to be doing, what it's supposed to be looking like over there. It's supposed to be giving you good data, but good data tends to be a little bit of a generic term. So, we're defining good data over here as well as data that is really accurate, that is timely, that is reliable, and most importantly, that's actionable. So you're actually doing something after you reported it or receive the data kind of coming in over there as well as have the ability to, on a near real-time basis, try and respond to those anomalies, errors, alarm conditions in the field itself as well. Without having a full SCADA-based supervisory control system over there, you want the data that is coming in to be actionable to a point where you can respond to those things in a near real-time manner over there. And that's what the Telog portfolio is meant to give you. Any good IoT solution, any proven IoT solution has to be easy and cost-effective to install. Easy and cost-effective can mean various things to different people over there as well, but really for us, it really means it has to be a rugged solution. We have to be mindful of the type of environment we are operating in. We're operating in sewers, in manholes, in underground vaults, stations over here as well. So it has to be rugged. It has to be wireless for it to be easy to deploy and easy to move around over there as well. If you have to have mains power to be able to operate your equipment, that solution is not easy to deploy and easy to move around. It has to be reliable in terms of its communication capabilities as well. So it's not just good enough to have devices in the field that are actually just collecting data if they don't have a reliable enough way to send the data back where it's going to be analyzed as well. And ultimately, it has to have a low cost of ownership, not just for the period of installation, but throughout the duration of its lifetime spent in the field over there. There's no point installing hundreds of these sensors in the field that cost you X amount of dollars per day, but it's going to cost you more to maintain that fleet of devices in the field than it is to than the value that you can extract from those devices that exist in the field over there. So Ravi, if you wouldn't mind going to the next slide over there. The way we define what a good IoT solution looks like is we break it down into what are the fundamentals of a good IoT performance monitoring solution. Good data, like we've said in the previous slide, is the foundation of a good end-to-end IoT solution. And although we understand that good data is reliable, it's secure, it's actionable over here as well, really, we define it in this hierarchy that you see on the screen over here. What do you get from your sensors? What are you doing with the data in the field? How are you converting that data that you get in the field into insights over there? The first one of that would be data that comes from sensors itself. So sensors is the very base level. Ravi, if you just would hit next over here on the slide. Sensors is the very base level of data that you're actually extracting from the field. So this is the data that you're measuring in the field. This is raw data from the field. This data can, think of the example of what you typically would get from a thermometer or, a home hygrometer as an example, right? This is just data that doesn't really mean anything. It's just giving you data for the sake of data over there. However, even on this particular level, on a sensor level, we want the data to be functional. So it has to be application specific. You don't want just a pressure recorder. You want a pressure recorder that's collecting pressure data specifically tuned and calibrated to the types of systems that we're looking to collect pressure data on. For temperature monitoring, as an example, you don't just want ambient temperature over here. You want to be able to determine what the temperature for that specific type of application is. Similarly for leak sensors, similarly for level sensors over here as well, the sensors that you're looking to collect have to be functional and tied to that particular application you're looking to measure the data for, such as the non-revenue, water, or the CSO applications we talked about on the previous slide. The data also has to be modular. These sensors itself, the reason we can build a good IoT solution in the field is if the data can be taken from different points in the field with the ability for the sensors to be as much as possible be plug and play. Plug and play doesn't necessarily mean you're taking just one sensor and putting it across your entire system, but you should have the ability to add or remove these sensors as and when needed. You should have the ability to connect to multiple devices as and when needed over here as well. And you should have the ability to bring in both your third-party sensors or any existing built-in sensors into your system as and when appropriate for you as well. So the combination of these three things would give you raw data in the field. Rami, could you hit next over here on that slide? Okay, we'll just kind of keep going then. Raw data from the field gets you to the next level above, which is how do you convert raw data to actionable data? Actionable data is something that comes from the next level above on that pyramid called remote telemetry units or recording telemetry units over there. These really are intelligent, smart data loggers over there that give you actionable data by providing you backup data storage capabilities. So, if you can't rely on the wellness of your communication systems for the wellness of your entire IoT portfolio. If your communications are down for whatever reason, you have to have the ability to have a backup storage for all of the data that you are collecting over here as well. You also want the data to be alarmable. So if any imminent action is needed on the field right away, if you need flow, if your flow on your system is rising rapidly, if your pressure has deployed, immediately, you want to be able to be alarmed about it immediately so you can take action on it right away. What you do not want to do is collect that data, have it sit in someone's Excel sheet or someone's graph over here and not do anything about it in the field over there. So the hardware in the field itself, the equipment itself, has to have the intelligence to report to someone, to notify someone from the field saying something has gone wrong, someone needs to look at it right away without going into any type of post-fault analysis type of insights over there as well. Then ultimately, these devices, RTUs, have to be scalable. So a good solution, like we talked about, is one that is cost-effective to deploy, right? That doesn't necessarily mean you have to have a sensor, all the sensors that can go into one particular site at one particular time. It also means that you have to have a system that can take in one sensor today. So let's say just flow monitoring. And in the future, if you want to monitor pressure from that site as well, or temperature, or level, or whatever else you might need to add, you have to have the ability to build on what you're collecting from the field in the field without having to replace your entire system from scratch over there. Another way the system has to be scalable is it has to be able to connect to both Trimble sensors, which we provide for specific applications, but there are always going to be edge cases where people would prefer or want to bring their own third-party sensors in. The Telog portfolio RTUs do have the ability to bring in any third-party sensor into the exact same hardware IoT platform to be able to provide insights on the data that you're collecting from those third-party sensors. As long as they can speak any of the standard industry protocols, Modbus, I2C, SDI12, any one of those, you have to have the ability to build a scalable, robust system to bring the data from those third-party devices and generate insights from those. So again, that gives you data measurement from sensors, actionable data coming from RTUs, and ultimately you need to be able to convert actionable data to actionable insights, right? So actionable data is by its very nature reactive in nature. Data is telling you what it's looking to the data is telling you what you need to be doing, and you're reacting based on the information you're getting from the field. You're not actually performing any analysis on that data to generate any insights. So the next step above from actionable data would then be insights. These insights need to be presented in a manner that's easy for anyone to digest. So that may be dashboards, that may be various trends that you're generating on the data over here, how your data is fluctuating over a period of time, how are you graphing that data either on a map, a GIS-based map, or just a generic, bar graph, pie chart, whatever the case is. You need to be able to not just bombard someone with actionable data, but make it digestible enough in a manner where they can go from always chasing whatever the current file is to generate insights from the data that's collected from the field over here and use that to provide actionable insights. For us, actionable insights over here can range anything from the Cityworks asset management system all the way to Trimble Unity remote monitoring. Rami, could you go to the next slide? Okay. So just as a recap, a summary of what the IoT portfolio itself will look like across the water cycle, right? On the water cycle, on the distribution side of things, your applications are going to drive what your IoT needs are. Your application always drives what you're actually looking to deploy in the field itself. So that can be flow monitoring, that can be pressure monitoring or hydrants monitoring over there as well, that can be leak detection, that can be just base level pressure monitoring across your vaults over there, or level monitoring over there. An example I'll share that kind of really paints all this picture together would be flow monitoring. So if you look at the very first blue bubble on the left of that chart that we have over here, that flow monitoring IoT portfolio includes an IFM32 sensor, which we'll talk about in a little bit more detail in the general session later today, that actually collects or measures data in a smart manner from the field that you can program, that you can generate insights on. That data then goes to the RU32 RTU, which you see in the background of that picture over there. A combination of the sensor and that RTU gives you actionable data that you're collecting from the field. And this data is then reported to Trimble Unity remote monitoring, which is where you generate the actionable insights from. Another example I'll share over here is on the wastewater side. So on the wastewater side over here, again, your application drives what your portfolio needs are, what your hardware equipment field needs are. Whether that's rainfall monitoring, that's open channel flow monitoring over here, sewer overflows, lift station monitoring, so on and so forth over here. On the open channel flow monitoring in particular, I'll highlight our recent launch of the Raven 2 wastewater radar-based sensor, which is a non-contact, no contact with the water in a pipe or an overflow condition, area velocity sensor over here as well. This is something that really would be thought of as a smart sensor. So it's a sensor that is completely self-calibrating, it's completely self-diagnosing in terms of it doesn't actually need someone to actually worry about maintaining the sensor in the field itself. And that actually then collects the data, reports it to the RU35 RTU, which we see on the picture over there, and then reports the wastewater CSO level and flow data to an insight platform such as Trimble Unity remote monitoring. And again, we have a question.
I'm sorry, let me give you a quick time check here. We got about 6 minutes totally left here in the session.
And with that, we'll back to Rami.
Thank you, Umar. And so all the data that is collected through the IoT sensors feed into our Trimble Unity remote monitoring and GIS-centric cloud and mobile software that offer advanced workflows and reporting tools to proactively monitor, measure, and improve asset performance. Also detect anomalies to preempt issues that can cause infrastructure damage or disruption of service. And you can quickly gain asset performance visibility and awareness in a few steps. So starting from using the Trimble Unity mobile app to install the Telog recorders and sensors in the field, then set up the sampling and recording intervals, any alarming thresholds to detect operational anomalies, and how events are raised. Then activate any performance KPIs you want to update in your GIS against the assets that are being monitored. And then use built-in reporting and analysis tools to monitor the distribution and collection system. And then you could use Cityworks Operational Insights, where you can develop an asset risk strategy which uses key data points stored in the GIS and allow you to define how this data go into play with the probability of failure calculations, consequence of failure, and business risk exposure. The calculations include factors like asset age, material, condition, repair history, and the KPIs that are calculated using our IoT data. Now, this analysis is then used to inform your action plan, to prioritize asset repair activities, perform more expansive monitoring, and enrich the analysis with asset replacement cost data to support capital improvement planning. And then from there, you could present and visualize all of this data in spatial contexts using ArcGIS dashboard and insights for data sharing, analysis, and reporting. These can be shared as part of your reporting and operational update process, but also allow your organization to review the data in real time as information is being captured and data is updated. So to summarize, the integration between Cityworks, Trimble Unity, IoT, and ArcGIS products create a unique and comprehensive digital platform with real-time asset intelligence, workflows, and analytics that help you gain better insights into the asset performance, shifting your focus from reactive to proactive asset management. And with that, you can reduce infrastructure failure and repair costs, improving customer service and response, and also use this real-time performance data to support business risk assessment to help you make informed decisions when prioritizing repair activities in high-risk areas and ease your regulatory compliance. Just quickly wanted to highlight that I'd like to invite you to join us tomorrow during the general session, where we're going to do a brief demonstration for this solution. And tomorrow the general session will start at 8:30 Mountain Time. Also, I'd like to invite you to join a couple of sessions, one presented by David and George on the wastewater application side for proactive flow and level monitoring to reduce and better manage sewer overflows. And Dinora will be providing a detailed presentation on the Cityworks operational insights for risk strategy and inform your decision making. With that, I'd like to open it up for questions.
We have one question that says, can Trimble Unity be used with meters and be integrated with Cityworks, similar to the valve exercising integration?
With meters?
Mm-hmm. Yes.
Yes. So you could create workflows the same way as the valve inspections. You could use any type of inspections that are configured in Cityworks. So you configure the template and the workflow in Cityworks, and that will seamlessly transition to Trimble Unity.
Excellent. Thanks so much. I don't see any other questions in the chat or in the questions list here. So that puts us pretty much right on time here, I suppose. So I wanted to thank everybody for joining us. We had a little bit of a technical difficulty with some slides freezing up on us there. So thanks for your patience. And thanks to Rami and Umar for delivering this presentation and giving us this information. At this time, the broadcast will stop, and we'll end this session and then invite you to return back to the lobby to select another session to start up next. Thank you guys so much.
Thanks, everyone.
Thanks, everyone.